Okay guys, quickly, our lesson 4. Welcome to physics, and this will be the last topic of physics. So we're going to quickly, the last topic is waves. Other questions have been answered. So we were doing this offline. Let's mark together. A photon of wavelength 2 times 10 to the power negative 7. I hope we remember the symbol. Wavelength is like that, right? It's located within the X-ray range of the electromagnetic spectrum. Write down the speed of this photon in a vacuum. Now, all electromagnetic waves travel at a constant speed. So our first answer there, that's why the examiner says write down 3.1. The speed of electromagnetic waves is what? C, which is 3 times 10 to the power 8 meters per second. And you can pick that from even your formula page. It's right there. Can you see? It says speed of light in a vacuum. Write down the speed of a photon in a vacuum. You see that, right? So all of these electromagnetic waves travel at the same speed. Now we know the wavelength and the speed. With physics, my dear learners, right from grade 10, I want you to learn this principle. If you can learn it and make it a lifestyle, you would be good with physics. Check with calculation. What is my wavelength? 2, what is it? Times 10 to the power negative 7. Okay, I have that. The examiner says calculate the frequency. Beautiful. Now you go to your formula page. Okay, what do I have? What do I need? Is there a formula that has what I have and what I need? C, lambda, and frequency. Okay, let's check. C. Oh, check it. C equals to F lambda. Case closed. 3 times 10 to the power 8. I do not know my frequency, but I know that. So what would you do? Please, I want to advise you, use this button on the calculator. Let me show you my own calculator. Please, when it comes to exponents, use this button. So 3 times 10 to the power 8 over 2 times 10 to the power negative 7. 1,5 times 10 to the power 15. And what is the unit? Hertz. Let me see your answers. Is that the answer you got? Let's see your answers. All right. Okay. But you didn't type them in. I said I wanted to see them. You didn't type those answers in. But you are forgiven. I forgive you. From the depth of my heart, I forgive you. Okay. So now let's move on. Let's move on. Let's move on. Calculate the energy. What is the symbol for energy? It is E. Let's go again. Okay, there are two formulas. E equals to F and E equals to HC over lambda. Do I have any of this? Yes. Oh, so we're done there. Number 3.3. Energy. The example formula page says E equals to HF, or we can use any of the two because I think we have all that we. Question is, what is H? H is known as Planck's constant. Let me remind you. H is known as what? Planck's constant. You will do this exactly like this again in grade 12. Question 10. Where do you get your Planck's constant? It's on the formula page. 6,63 times 10 to the power negative 34. Oh, great. So we're done now. So E equals to 6,63 times 10 to the power negative 34. What is my frequency, by the way? My frequency 1,5 times 10 to the power 15. I'm going to grab a calculator and quickly. So it is important to know what you have. That is what will determine the formula you use. Check. I have 9,945, but physics is 2 decimal places, so it's 95. 9,95 times 10 to the power negative 19 joules of energy. Or let's check the second one. HC over that. 6,63. We just substitute in. Once you know your formula, times 3 times 10 to the power 8. What is your wavelength? Your wavelength is 2 times 10 to the power negative 7. Let's get a calculator and we throw that in. 6,63 times 10 to the power negative 34 times 3 times 10 to the power 8 over 2 times 10 to the power negative 7. Check your answer. Perfectly the same answer. 9,95 times 10 to the power negative 19. But remember, joules. So once you have your variables, it is very easy to pick a formula. And that's the mistake that many people make. They just want to calculate without writing down variables. Physics becomes difficult when we do that. Please let me know. Give me a thumbs up if we are okay. Give me a thumbs up if we are okay with that explanation and reminder. All right, we are okay. Beautiful. Now let's look at the last one quickly. The wavelength of the photon is doubled. Will the penetrating ability of the photon increase, decrease, or remain the same? Explain your answer. All right. When the examiner says penetrating ability, the examiner is referring to the energy. My beautiful learners, let's go and do physics now. Let's look at the formulas. We always use the formulas. All right. Examiner talks about the wavelength. So, let me remind you, what is the relationship between energy and wavelength? I'm going to write my formula. E equals to hc over lambda. All right. So you would notice these two are constants. Oh, and because that is a constant, what's going to happen? Since hc is a constant, you know what it means? It means E is inversely proportional to wavelength. What are we saying? The longer the wavelength, and this is I'm already explaining, the smaller the energy. So, if wavelength is doubled, and I'm going to extend my explanation. Energy is halved. I want to explain that because this will come to us in multiple choice. Just hold on writing. I know you want to write, but please quickly hold on. I'm going to say E equals to HC. This is the original one, right? Now, lambda is doubled. Please watch this. So it means our lambda nu is 2 times the old one. I want you to see the multiple choice part of this question. What is our new E? Okay, our new E will be HC over lambda nu. But what is lambda nu? 2 lambda. Oh, my beautiful learners, now check. What is this? If we go back to this, do you notice that entire thing there is E? So this becomes what? E. The examiners like to do this in multiple choice. They like to do that. But so the main answer will be, our answer would be, let me quickly show you something here. I'll come back to that page. So what are we saying? It will decrease. And what is the explanation? That is the explanation. And I went further. Please write that down as quickly as we can. All right, we should all be done. Can I move to the next question? Can I move to the next question? And I hope it makes sense. Let me, giving me a thumbs up says you're done and you understand what I explained, right? The longer the wavelength, can I deal with the issue of the frequency as well? Let me use the same explanation and just extend this information. What about frequency? Relationship between E and E and frequency. What's our you use the formula? Oh, that is a constant. Since H is a constant, E is directly proportional to F. The higher the frequency, the bigger the energy. Your spectrum have your X-rays and you have your gamma rays, if you remember that thing there. So if you remember, we said that as you move down from wavelength decreases, and what energy increases. All of these are in your note. We just need to remember. As frequency increases, energy increases. Okay, let's add this to that note since it's a summary.
Disconnected.
Okay, done. So we can go to the next question. I want us to do some multiple choice as well. Okay, a lot of us are still writing. All right, thank you for those feedback that you are done. Everybody now done. Let's see who's remaining. Give me a thumbs down if you are not done so I can see. I got a few thumbs up. Okay, Gift is still busy. BB is done. All right. Question. This is just 6 marks. All right. All right, guys, let's see. This is just 6 marks calculation or so. A section of wave is represented below. The frequency of the wave is 2,5. Now, please let us make sure we are able. There are 3 definitions on this page that no 4 definitions that I want on this page. You're going to just write them down for me after we do this question. I'll write the definitions down. I need us to define frequency of a wave. I need us to define the wavelength of a wave. I need us to define transverse waves. I need us to define longitudinal waves. And I need us to define a pulse. 5 definitions. All right. So the frequency of this wave is 2,5 hertz. Is this a transverse or a longitudinal? This is a transverse wave. I'm going to check if you know how to define. If you know how to define, then you will understand when I said it is a transverse wave. So I'm going to wait for you to define. Calculate the speed. Again, I need V. What do I know? Let's check. I know frequency, right? Okay. Which is F. Can I get the wavelength? I think isn't 0,3 meters the wavelength? From one point on the wave to the next successive point in phase. Because that gives me a full wave. That is a quarter, half, and a quarter. Oh, this is my wavelength. And I know the frequency. So I think we are done there. What will be my answer? You are going to mark V equals to, I know frequency and I know wavelength. What is my frequency? 2,5. What is my wavelength? 0,3. So what would my answer be? That would be 0,75 meters per second. I want to believe that's the same thing that you got. Thumbs up, thumbs down. Is that the same thing that we got? All right, beautiful. Now, let's check the next question. Determine the time X between point A and B. Interesting. We are looking for time. But there is a general formula that we know right from grade thing when we talk about the DST, where we know that distance equals to what? The speed of the wave over the time. Okay, I don't know the distance. That's what I'm looking for. But I do have my wave 0, no, I'm looking for what? Time. Sorry. I'm looking for time. The question is, what is the distance of this wave? Let's go back, everybody. There are a few ways to do this, but I want to go for the simplest. If this here, and I don't know how you interpret it, if this here is 0,3, I notice that this here is half, because that is a quarter and another quarter. Oh, so that will be the half of 0,3. So 0,3 divided by 2, 0,15. But if I come to the right hand side, what do you notice? It's not half, it's just a quarter of 0,3. Oh, so what will this one be? 0,3 divided by 4, and that would be 0,75, I think. Let me know if my measurement, before we continue, let me know if my measurement makes sense with you. Please, thumbs up, thumbs down. Let's pause a bit. Is my measurement making sense with you? The wavelength is 0,3. But if we check the other part, I've got half and I've got a quarter. Oh, So what is my total distance? 0,15 plus 0,3 plus 0, what? 75. 0,15 plus 0,3 plus 0,075. What's that giving us? 0,525. Oh, sweet. Then we are done. So everyone knows how I got that, right? So what do? We can cross multiply. 0,525t is equal to 0,75. Let's divide. 0,75 divided by 0,525. Let's see, what is our answer going to be? Oh, I need a calculator now. And I want to check something else. 0,75 divided by 0,525. I'm having 1,43, 2 decimal places. Is this what you got? Dear Rouge, okay, we're going to come back and check that. All right, I see a lot of thumbs down. Okay, let's go back. Let's try to re-explain. Then we'll see, can we also use the period of a wave? But let's go back to explain. All right, let me draw here. So we have half a wave. There we go. So here is my full wave. We agree that that's a full wave, right? 0,3. That is half. 0,3 divided by 2. This is a quarter. 0,3. Do we agree with this? Let me know first. Do we agree with that? That the total distance there is that. Do we all agree? Let's go step by step. Great. So we agree that the total distance here, let's re-add to make sure that we are correct. Total distance, we said 0,3 divided by 2, that's the half, plus 0,3 plus the quarter of the wave. What did I do? What did I add earlier on? Oh, this one is over 2. Over 2 here. Alright, so we all agree that the total distance here, and we already know the speed of this wave. What is our speed? 0,75. Okay, we all agree. And we all agree with the DST that distance is speed over time. And my distance is the total length of the wave, distance traveled, 525. What is my speed? 0,75 over t. So t, therefore, after cross multiplying, like I explained, and dividing, all right, get a calculator again to confirm. 0,75 divided by 0,525, 10 over 7, 1,43. Do you agree with me for now? It's time. Why am I saying that? Do you agree with me? Is my step making sense? Do we agree? Okay. Now, let us try something else. I know you want to write, but let's try something else quickly, everybody. How many waves do we have here? Don't worry, I didn't clean this. I created another one. How many waves can you tell me that we have here? We have one full wave plus a half plus a quarter. Do we agree? One full wave in the middle, half there and a quarter there. Everybody agree with me? So how many waves in total? One plus a half plus a quarter. 1,75. So 1,75 waves. Okay. 1,75 waves. How long will it take one wave to travel, which is the frequency? Time for one complete wave. That is known as the period. And what do we know? T equals to 1 over F, 1 over 2,5. This is how long it will take one wave. All right? If you want, we can get an answer for this one. 1 over 2,5. This is for one wave, which is 2,5, 0,4. Okay. If one wave travels in 0,4 seconds, how long will it take 1,75 waves? Since we're looking for t, what do? We cross multiply. 0,4. Let's check this answer. Times 1,75. Boom. 0,4 times 1,7. Why is it giving me that? It's not supposed to give me, because the period is, it's supposed to give me that and times 1,75. Let's check. Why am I getting a different answer? Why am I getting a different answer? It's supposed to give us the same answer. Let me check again. Yeah. The frequency of the wave is 2,5. So we are looking for the time for 1,75. Let's check again. 1,75 waves. That one we all agree. We all are in agreement to that. All right, we all are in agreement to that. Then we said the period is the time taken for one complete wave. One complete wave, 1 over 2,5, which is 0,4. So if one wave travels 0,4 seconds, 1,75, okay, something is fishing somewhere. 1 second, let me just check something. 1,75 times 0,4. What did that answer give me again? It gave me 7 over 10, 0,7. That's not right. Am I missing something there? Am I missing something? Or, okay, wait. Could this other calculation be wrong? Could this other one be wrong? Guys, wait. I said distance is what? That's where the error is. That's where the error is. I see where the error is. Let's go. Okay, what is the time here? And you guys did not correct me. This one is what? We got 0,7, right? You guys did not correct me. Distance. Ooh, this formula is wrong. Speed is distance over time. You guys accepted my mistake. Now, So 0.75 is distance. And what is the total? Okay, we know the distance. The distance. Ooh, guys, you just accepted my error like that. What is the distance? 0.525. And I'm looking for what? Time. All right, let's cross multiply. 0.75 t. All right, what is t? 0.5. It's the other way. I made a mistake with the formula. Let's throw in our calculator now. 0.5. And you guys said you agree with me. Ooh, you guys don't know physics. Check. 0.7. You guys don't know physics. You agree with me with my wrong formula. Jeez, people. What's going on with you? De Rouge. Gift. I wrote that formula wrong and you agreed. What happened? Lino, Bibi. You were scared to say your formula is wrong. De Rouge, I'm going to so much shout on you tomorrow. You and Bibi, you are in trouble. And Zahra, you are in trouble since you are the ones I'm going to see. That formula is wrong. It's speed equals to distance over. Okay, all right, I forgive you. But do you see my mistake though? It's the form. I wrote the formula wrong. I think in my head I had already done the whole thing. So speed is distance over time. Guys, are we okay? So whichever method we use, we're getting 0.7. Thank God we tried to use the other method of one wave. Let me clean this. This is such a big mess. Please forgive my error. I'm tired as well. Okay, but that's no excuse. That is no excuse for a teacher. I should be fired. And if I get fired, I'm taking all of you with me. If Crazy Physics fires me, I'm taking all of you with me. Because you have all done physics, you know the formula, and you accepted the wrong formula from me. But are we okay? 2.1.3. Everybody good now? Everybody good? Okay. All right. That's why we have a formula page that we should write formulas from. Now, let's look at the last question. Let's look at the last question. And I wanted us to do some multiple choice, man. All right, let's read this question together. The question is on the next page. But I'm going to give you about 5 minutes to try. Ships use sonar. Sonar is sound navigation and ranging. All right, that's where the definition comes from. To map and measure the depth of the ocean at different points. This is achieved by emitting sound waves into the sea and detecting the reflected sound. This is what we call the echo of a sound. The sound wave emitted by a sonar on a ship takes 0.8 seconds to reach point P. All right, please take note of that. 0.8 seconds to reach point P, which is on the seabed, 1,200 meters. So we have our time, 0.8. We have our distance, 1,002. Q is a second point on the seabed as shown. Are you okay with the question so far? We've read the question. There are 2 points in the sea, point P and point Q. Point P, 1,200 meters, time 0.8 seconds. Here is the first question. Calculate the speed of sound in water at point P. You have 3 minutes. Speed of sound in water at point P. Quickly, everybody. You have the formulas. Speed of sound in water at point P. Quickly, 3 marks. Everybody. I don't want to give you more than 3 minutes for this. You have the formulas. All right, I believe everyone should be done. Let's write again. You should be done. What do we know? We know the distance, 1,200 meters. We know the time. Okay, we're looking for speed. Oh, let's make that mistake again. Speed is what? Distance over time. What do we have? 1200 over 0.8. And what would our answer be? That should be about 1,500 something. No, it should be 1,005 divided by 0.8. Perfect. 1,005. Please remember, in physics, unit is very, very key. Are we okay with those 3 marks? Just by writing what you know, look at it, I wrote it on the question paper, and we go with the formula page. We are done with that. Simple, straightforward, and done. All right, let's look at the last question. It is estimated that the speed of sound in water increases by 4.5 meters per second for every 1 degree increase in temperature. What does that mean? Oh, it means if the temperature increases by 1, the speed of sound also increases by 4.5. Okay, let's see. The temperature of the seawater at point Q is 2 degrees Celsius higher. Wait, than P. Let's stop there. We are saying that, let's see. All right. For every 1 degree rise, speed will increase by 4.5. But point Q is 2 degrees higher. Oh, it makes sense. It makes sense. So, if 1 degree speed increased by what? 4.5 meters per second. What about 2 degrees rise? It's going to be what? Okay, let's say we don't know speed. We cross multiply there. V would be what? 4.5 times 2, which is what? 9 meters per second increase in speed. Let me know if that makes sense to you, everybody. Let me know if that makes sense. We're just interpreting. We're not yet even into the question. We're just interpreting as quickly as possible. Interpreting as quickly as possible. All right. When a wave is emitted directly from point Q, the reflected sound is detected 2.5 seconds later. Wait, please get it. It says the detected sound. When a sound wave is emitted directly above point Q, okay, we see the diagram there. The reflected sound is detected 2.5. Wait, the reflected means it has traveled and it has gone back. That is an echo. Please always watch out for those things. That is an echo, which means sound comes down and goes up, and the total time is 2.5. What is the time for one trip? For one flow will therefore be what? 2.5 divided by 2, 1.25 seconds. Please, does that make sense? So you're walking to and walking back for 2.5 seconds. But if you're just walking one trip, it is 1.25 down and 1.25 seconds up. That's the echo, principle of echo. All right. I want to finish this, just 2 minutes. Determine the depth of the sea at Q. Interesting. How do we calculate? We are looking for depth, distance. What do we know? Speed is distance. I would not forget this formula, guys. What is the speed? Hold on, my dear learners. Check something. Let me go back to the diagram. We got the speed here as 1,500 seconds. But as the temperature increases, the speed also does what? Increase. And we got our increase as 9 meters per second increase. Can we conclude now, my lovely people, that the speed here is 1509 meters per second? Please let me know. For every 1 degree rise, it is 4,5. Now we have a 2 degree rise, which is 4,5 plus 4,5. That gives me 9. If our old speed was 1,005, our new speed becomes 1,509. Please let me know, my beautiful people. My beautiful people, I'm waiting. I only got 1 thumbs up. If you are lost, let me know. Once we get that, we are done with this question. Somebody is still lost. Okay, this guy is saying so many things. What are you saying, sir? Here is what I mean. Here's what I mean. Check this. I need white. Alright, we're here. Our speed is 1,500. Now, when we go 1 temperature degree higher, it increases by 4,5. So we have gone 1 degree increase in temperature. If we go another 1 degree, another 1 degree rise, what are we going to have? The old one is 4,5. We've gone another 1 degree. For every 1 degree that we go, it's 4,5. So what do we have? 1509 meters per second. Does that make sense now to you? Speed is distance over time. What is my speed? 1509. I do not know my distance. But what is the time? 1,25. I hope you remember how we got the 1,25. What is the distance therefore? Next week we are looking at chemistry. But before that, we will answer some multiple choice in physics, which I will send to you today. 1886,25. 1886,25. Let me know if we are okay with that. But let me know if there's any question you want to ask about what I explained. Everybody good? Thank you, Gift. Deruj good. Zahra, you okay? Misho, I think I saw your hand. Nodutando, you're good. Bibi, awesome. Good. Namtando Lino, awesome. Nolutando, great. Makati, are we okay? Njubo, are we okay? Guys, quickly take pictures of this multiple choice, please. And somebody send it on the group. Quickly. Quickly. Take a picture. Take a picture and just send. Somebody's taking the first one. Somebody's ready to take the second one. First one should be done. So we take it differently. Ruch, you took this one, I guess. Zachra, screenshot quickly. So everybody's taking one and send to the group. All right, Zachra, you got that. Gift, you ready for number 3? Just screenshot and send quickly. Send. Make sure you're next, and then BB, you're next. I think there are 5. Gift, you got that. Send to the group. Michelle, come quickly. And any other person can take. Nolutando and BB, you have not taken. Take that. Send to the group. I need those questions done. Multiple choice. Once we have them, thank you. I only got the root one. Okay, which one is missing? I'm not sure which one is missing. Which one is missing? Okay, I'm sure you guys took the 5. Let's see which one is missing. I'm not sure for 4. Did somebody take 4? Okay, we just need to make sure that we have the 5. Somebody should have taken the 4 now. The 3. I think this was the one Zakra was supposed to take. All right, we should all have the 5 now. And number 2. I know Derich took the first one. All right, have a lovely evening, everybody. So in an exam, you'll remember my mistake, right? And you won't make it. But I'm still going to shout at some people tomorrow when I see them. I'm still going to shout them. Don't run away from me. I'm coming to your class to find you. Have a lovely, lovely evening, everybody. Goodbye. It's okay. Goodbye.